No wind today. It's about 57 degrees, drizzling slightly. Barometric pressure is...
Clearly he was pretty interested in this stuff, which quickly led to the close examination of gases.
By golly, those other scientists were wrong! This is not a chemical solvent. It's a mechanical system made of itsy-bitsy particles that use pressure applied by each gas individually.
It is what he called Dalton's law.
So he has a book and a law?
Yeah, technically, and a theory.
When are we going to get to that at thing again?
Just a second. Anyway, his fascination with gases slowly but surely led him to figure something else out.
Everything is made up of particles. Everything is made up of individual particles. Let's see. Democritus. His ideas are a bit out of date, but I think I'll use his terms to name these particles atoms.
He created the first set of atomic weights when writing an article in 1803.
Yes, geez, this guy created a lot of first.
He sure did. He decided to expand on this theory, so he wrote about it in his new book in 1808.
Atoms of different elements have different atomic weights, and atoms cannot be created or destroyed.
This was the beginning of his atomic theory. Now, his theory in more detail. For one thing, it had 5 parts.
Part 1. All matter is made of tiny particles. Atoms are tiny things, building blocks if you will. They make up every form of matter. Part 2. These atoms cannot be changed or destroyed or transformed. Part 3. Elements are characterized by mass of their atoms. All atoms of the same element have the same weight, and atoms of different elements have different weights.
Wait, isn't it mass, not weight?
Yes, but Dalton used the word weight instead of mass, and a lot of chemists have called atomic mass atomic weight ever since.
Does this guy just make up his own rules?
Not quite sure.
Part 4. Atoms of an element sometimes combined in simple whole number ratios when the element reacts. Basically, compounds are produced throughout the different whole number combinations of an atom, and the whole thing helps determine the relative atomic weights. Now, Part 5. When elements react, their atoms sometimes combine in more one simple whole number ratios. A chemical reaction results in the atoms being rearranged. Ever wonder why weight ratios in nitrogen to oxygen and different nitrogen oxides are multiples of each other? Well, this is why.
I thought there was just 5.
Well, yes and no. There were 5 correct ones, but there was an additional postulate that was incorrect.
Listen! Part 6. When atoms combine in the only one ratio, it must be presumed to be a binary one, unless some cause appear to the contrary.
Poor Dalton accidentally thought that the formula for water was OH, and the formula for ammonia was NH, which caused the atomic weights for nitrogen and oxygen to be wrong.
But it was an honest mistake, right? Didn't the people realize that?
Unfortunately, not at first. It took a while for his ideas to be accepted because of it.
How did they finally decide to accept it?
Accepted and applied only once a consistent set of atomic weights was made. Then they realized that most of his theory was correct and important. And he really was a good scientist. After all, he reached all of his conclusions by experimenting and examining results. This made his theory the first truly scientific one of the atom.
Cool. Did he have any other flaws beside the one in his theory?
Yes, many. But he's only human, right?
Right.
This sphere right here is an atom. They cannot be broken down any further.
He had no concept of subatomic particles.
Remember, atoms only combine in simple whole number ratios. For water, HO, one oxygen atom combines with one hydrogen atom.
Unfortunately, he had no clue about electrons. However, despite those few flaws, a bunch of big ideas of his are important and used often today, including the fact that matter is not destroyed or created in a chemical reaction, and chemical equations have to be balanced so that the number of atoms from start to end is the same.
That's great. Did Dalton base any of his work off of other people? I mean, I'm sure he was smart, but a whole theory is a lot to come up with by himself.
I'm sure he was influenced slightly by Democritus, who discovered the existence of particles and came up with a name for the atom. He also studied and expanded on Antoine Lavoisier's and Louis Pasteur's work. A lot of what he came up with due simply to his own experimentation, though. He was a smart man.
Why, thank you.
You